All right, how's everybody today? They're doing well? Okay. So we're halfway through the week. Don't forget, tomorrow is your test. 10 multiple choice questions. It's still working off the identities that we have here. You won't see any equations like we have been. You won't choose one side and get to the other. You'll just go ahead and simplify, like the previous lesson. You picked up the homework today. It's going to be due on Friday. So in fact, I think we're actually really close to the end. In fact, I think we only have the one problem left, and then we can go ahead and start looking at the problems. Now, I am going to go ahead and cut it down a little bit for you. So on the homework assignment, which you see right here, I believe it goes to 27, but you only are going to be responsible for the evens. Okay, you only have to do the evens on the assignment. So if you want to go ahead and do the odds, maybe as a little extra practice, go ahead and feel free to do so. But I mean, it is really good, practice for the exam tomorrow using these identities. Okay, so I'm going to go ahead and provide you pretty much the majority of the period, hopefully, to go ahead, begin this if you haven't already. Help each other out. We can probably do a couple together. But let's go ahead and wrap up the notes. Let's see here. So this is our last example. Prove that secant squared of x times cosecant squared of x equals secant squared of x plus cosecant squared of x. Okay. So here's the thing. We can start on either side, completely your choice, whichever you believe is going to be the more beneficial. We can use algebra techniques, the identities. We just have to show one side equals the other. So you want to start with the left side? Okay. So let's start with secant squared x cosecant squared of x. And we somehow want to end up with secant squared plus cosecant squared. Okay. So would there be anybody willing to come on up and show me this problem? Now remember, is there more than one way? There's always more than one way. Brandon, you want to do it?
Yeah, I can do it.
Okay. He thinks he has a way. All right.
No, I don't. I'm going to do it while
Okay, that works too. And we will help you out. So at least we know where we want to get to.
So we're going to go ahead and we're going to change these so that you have 1 over.
Okay, so secant is 1 over cosine, and we keep the squared. Same for 1 over sine squared. Okay, perfect.
And then we're going to cross multiply, right?
Now we can't cross multiply because it's not an equation.
Oh, yeah. So then we got
Right now we're just dealing with the expression.
have these the same so they can go into each other. So sine squared and sine squared.
Well, okay, also I see what you're doing. You're trying to get a common denominator, which is good, but they're already multiplied together. So see, we're not adding or subtracting them, so we don't need to do that.
The right side we could have did that. See, that's... Wait.
We could. In fact, I was thinking that, but where would we put it?
Because we could add a secant or cosecant 1, right? So we could get tangent or cotangent out of it? Or 1? Like
Tangent or cotangent.
1 plus tangent, because like this one right here uses cotangent, and then this one right here uses tangent. Do you know what I mean? In the Pythagorean identities?
Oh, I see what you mean. We could break those apart and then multiply that. We could, yeah. So we have two possible ideas right now. Lexi has the idea, could we use a Pythagorean identity with, say, cosine and sine? Or Brandon has the identity, secant squared and cosecant squared, and then we can multiply those together. Either of those are going to work. As long as you're using those identities, you should be able to get to where you need to. But who was it who said something about getting a plus in there? Okay. I like Lexi's idea because that allows us to immediately do something.
So could we do like 1 over?
Oh yeah, we could multiply them together and just have one fraction.
Okay, so then would that be like cosine squared and then sine squared? Would I have to write it like that?
You could do it like that. That'd be perfect.
Okay, so if I have it like that.
Now see, what Pythagorean identity could I use to introduce that plus like Lexi was talking about?
And then that'd be
But where?
1? Like, what do you mean? I'm scared.
Okay. This one's not as obvious. Do you want me to kind of help you out?
No, we got you.
Oh, you got it? Okay.
You got this.
Okay.
Okay, So if we like pull this one out, right? We have like 1 over cosine squared,
Uh-huh.
and then we have it like plus sine squared, right? Could we do it like that?
But
Like
how do we get the plus, though?
because we're pulling it out.
Because the sine squared could be 1 plus. Oh, wait, we could do 1 plus cosine squared on the outside. Oh, wait.
1 plus
Cause
cosine
like,
squared.
can't you like pull these out? Like,
Well, you can separate them, but it'll still be joined by multiplication.
Well, if we keep that 1 plus cosine, or 1 over cosine squared, that'd be secant squared.
Okay. So see, yeah, the way we are right now, we can immediately go back to secant squared, cosecant squared, but somehow we got to get that plus in there.
okay, so if we just
Oh, go ahead.
no, you good. Go ahead.
Sure?
Yeah.
Okay. For the sine squared, could we put 1 plus cosine squared?
You're close. It would be 1 minus cosine squared.
Hold on.
So 1 minus cosine squared.
Hold on.
Cause okay, so if we like kind of like break those apart or not like break them apart, we could get like so it could get 1 plus tangent squared
Yeah.
times cosecant squared, but then tangent we know, so we can have 1 plus sine over cosine squared, and then since we can change this into that 1 sine squared, 1 sine, okay, okay,
Okay, I think I see where you're headed with this.
so 1 plus sine squared over cosine squared.
And let's go ahead and put that whole thing in parentheses.
Oh, this one?
Yeah.
Okay.
No, the binomial, I'm sorry. There we go.
Okay, and then times sine squared, and then but this because over 1, right?
Now, remember, you have that multiplied by cosecant squared, so you can multiply it by 1 over sine squared.
And then we can cross the sine squareds out, right?
Okay. And here, you need to do one thing, though. When I was talking about the parentheses, put this and that in parentheses because your secant squared became the 1 plus tangent squared, right?
Yeah.
So you see, now we have to distribute the 1 plus sine squared across that binomial.
So like 1.
And you're going to get what you need.
So this 1 times that would give you like 1 sine squared.
Okay. Yeah, so 1 times 1 over sine squared would give you 1 over sine squared.
Okay.
And then plus,
And then
what's going to happen when you multiply sine squared over cosine squared times 1 over sine squared?
it's gonna be like 1 over sine squared over sine squared plus sine squared. It's gonna
Actually, you mentioned it a moment ago, something you wanted to happen.
cross these out.
The sine squares are going to cancel, and I'd be left with
1 over cosine squared.
1 over cosine squared.
Gosh.
And what is 1 over sine squared?
Oh, oh.
And then 1 over sine squared is?
Yeah, and that's that right there. Secant squared plus cosecant squared.
There you go.
And that's
And that is QED. Good. I kind of think of these as like little puzzles. Okay. That's good. I didn't think about replacing secant squared with 1 plus tangent squared. Is everybody okay with what he did?
And again, just to reiterate, it doesn't matter what order they're in. If you get
Oh, no. Secant squared plus cosecant squared is the same as this. If you had cosecant squared plus secant squared, addition and multiplication are both commutative. So that doesn't matter. Order does not play a part here. Okay. Would you like to see quickly what I did? Okay. So that's really good. I always like to see new methods. So what I did, I started with the left side as well. So I said that's 1 over cosine squared. Cosecant squared is 1 over sine squared. So I just multiplied those together and had 1 over cosine squared times sine squared. Okay, so this is how he originally started, right? Now, I was talking about using a Pythagorean identity, but it may not have been very obvious. Remember that sine squared plus cosine squared equals what? 1. So see, I can replace that 1. That's how I got my plus in there. So sine squared of x plus cosine squared of x over cosine squared sine squared. And we've actually seen this rule before. You need a common denominator to join fractions, but you can do what? You can separate them. Each numerator will have the same denominator. So I can have sine squared over cosine squared, sine squared, plus, then I have the cosine squared over cosine squared, sine squared. And then you'll notice when I break them apart, now I can do what? Sine squareds cancel, cosine squareds cancel. 1 over cosine squared is secant squared, and 1 over sine squared is cosecant squared. Okay. And that's good. I really like your method too. I haven't seen it done that way before. Okay. And it just goes to show there are going to be a lot of different ways to do these. As long as you're following those identities, you should always be able to get to where you need to. Okay. Very good. And then I'll go ahead and put QED as well. All right. Good. Questions? All right. Well, let's go ahead and do this. We have the homework assignment, but you're only responsible for what? The evens. Okay, it's going to be due on Friday. So, bless you, sir. Let's go ahead and do a couple together. Which ones would you like to do together? So basically 2 through 26 evens. Bless you. What examples would you like to work together? Hey, number 16. Okay, let's take a look at what that looks like. Okay, number 16. Okay, so I've got secant of x over cosecant x plus sine of x over cosine x equals 2 tangent of x. Okay. So, what side would you like to start on, left or right? Probably the left. I think there's a lot more opportunity there to change things up. Okay, so ideas. How can I make the sum of those two fractions look like 2 tangent?
We could start off with sine and cosine, making that tangent already.
Okay. Now, is it going to be tangent? Because this first part here, secant, is 1 over cosine. Oh, so you want to change this one?
Yeah.
Oh, okay. So would you like me to do anything with the first part?
Well, yeah, the first part we could do how you were doing it.
Okay, so you do want to do that? Okay. So let's see. 1 over cosine divided by, that's 1 over sine of x.
We could take the reciprocal, and then that would be like...
Perfect. I see where you're going. We're going to take the reciprocal of that. So this is 1 over cosine x times sine x over 1, which is just sine x over cosine x, which is equal to tangent of x. And then you've got this guy right here. He's absolutely right. If you change sine over cosine right back to tangent, tangent plus tangent is 2 tangent of x. Perfect. Very good. Excellent. Okay. And that's all you got to do. Okay. On these later problems, just choose one side and somehow rewrite it to get the other. All right. Good. Okay, so one down. What else?
How many do we get?
Yeah, we'll work like 3 or 4 together. What else would we like?
Can you just go to 26 real quick?
26.
I'm not saying work it.
Okay.
I'm just saying, like, just so I can
Uh-huh. It's not on your paper? Oh, sorry. Copy machine, yeah. Hopefully before the end of the school year, they're thinking right after spring break, we're going to go to what they're calling hubs. So all the copy machines that are in the lounge and so forth, they should be removing those, and then they're going to place stations around the campus. So like within 5 doors of me, there should be a copy machine that all the teachers around me are going to be using, and we're going to see if that's going to work out. I don't know. We shall see. But that's our plan. That's our plan. Because those copy machines, yeah, they're old. They're super old. What? Oh, okay. All right. So what would you like to work? 16? 16? Didn't we just do 16? 18. Okay. 18. Tangent of y minus secant squared y over tangent y equals negative cotangent y. They can't just cross out because of the minus. Now, if we were multiplying, absolutely. All right. So what could I do here? I'm probably going to go ahead and start with the left side, I imagine. Okay. Okay. So you want tangent of y minus, so secant squared would be 1 over cosine squared, and that's all divided by sine of y over cosine of y. Okay, so I'm going to take the reciprocal of this guy right here. So tangent of y minus, this is 1 over cosine squared times, so I'm going to flip. It did it again. It's always during fifth period, too. Oh, okay. Okay, so let me pull that back up again. Yes, they do, but unfortunately, the reason I'm having so many problems is because with the last update, the software doesn't really want to communicate with the software that I have, like in other applications. Like it really doesn't like talking to my document camera at all now. So the update actually put me in a worse position than when I sent in a ticket. But let's see, what number were we on? 18. Was it 18? Okay, so unfortunately it took off the work that I was showing. Okay, so let me catch back up. So tangent of y minus, this was 1 over cosine squared. This was sine, oh, it's y, I'm sorry. Sine of y over cosine of y. We're going to multiply by the reciprocal. So tangent of y minus 1 over cosine squared of y times, now I'm going to take the reciprocal of this, cosine of y over sine of y, and what can happen? Okay, so one of the cosines can cancel. Now what? Did you want me to rewrite the tangent or leave him as is?
What would like the fraction be? Would it be like cosine of sine? Cross multiply?
Again, we can't cross multiply. But if I were to multiply these together, this would be minus 1 over, because that's all that's left, cosine of y, sine of y.
Okay, and then, yeah, okay, so the tangent, yeah, we can make it sine and cosine.
Let me move this over a little bit so I have a little more room. Okay, so you want me to go ahead and make tangent sine over cosine y.
Yeah. And then, could it be times both side by sine? Or like, we could times the left side by sine, right?
Just the left side, because the common denominator would be cosine sine, right? So this is an example where I already have a denominator that I don't need to touch.
So you end up getting like negative cosine squared.
Okay. Well, let's see. If I multiply these, that would be sine squared y over cosine y sine y minus 1 over the cosine y times sine y.
So you can get sine squared y minus 1
Okay.
put that.
All right, so now I have a common denominator. So I'm going to pull them together. So this is all over cosine y, sine y. So let me go ahead and write this out. That would be the first numerator minus the second.
So then that's what that would be. Sine squared plus cosine squared equals 1.
Uh-huh.
Subtract 1 and cosine, it should give you negative cosine squared on top.
That's exactly right. Does anybody want me to write that over to the side, what Brandon was talking about? Again, he's talking about just manipulating the Pythagorean identity, but you're going to subtract the 1 over and then have to subtract the cosine squared. Does anybody want me to show that? Okay, let me go ahead and show you. So cosine squared plus sine squared equals 1. So if I go ahead and subtract the 1 over cosine squared plus sine squared minus 1 is equal to 0 because the opposites cancel. So see, I've got the sine squared y minus 1, but I've still got the cosine squared on the same side. So I'm going to have to subtract him over as well. So sine squared y minus 1, when those cancel, should equal negative cosine squared of y. Now, this actually works out nicely because you notice the other side is what? Is negative. So at some point we had to incorporate a negative in there. So I'm going to take the sine squared minus 1, and I'm going to replace it with that negative cosine squared y. Yes. Okay, so is everybody okay with what I did? So she's absolutely right. This cosine would cancel with one cosine above. Now we know that my answer has to be negative. And what is cosine divided by sine? Cotangent. And is that what we were trying to get? Yes. Negative cotangent y. And there we go. So this one, I mean, when we're grading this, you're going to notice on the key, there's no answer there. Okay? Because you already know what your last statement needs to be. It's just getting there. It's the process. So it's going to be really one of two things. If you're able to choose one side and get to the other, go ahead and give yourself credit. But if for some reason you weren't able to work the problem, or you skipped it, or you were not able to get to the other side, that's when we'll go ahead and count it wrong. Okay. But on the first part, I want to say like numbers 1 through 9, there are answers that you want to go ahead and get to. So in your case, through 8. Okay. Oh, and actually looking at this, let me make sure number 8. Oh, yeah, that was good. It's different on my paper. I remember thinking that for IS, because on my paper it gives you a double angle identity, and we have not talked about those yet, so that's cool. That's good. Okay. All right. Let's go another one. What other one would you like to work together? Every one of these should work. The only ones that could possibly be not, number 7 through 9, tell whether it is an identity or not. So the answers here for 7, 8, 9 are actually yes or no. But every other one should work out. There should be some way to get from one side to the other. You want to do 6? Okay, sure. Multiply each expression by the indicated fraction. Okay, so I have cotangent over 1 plus cosecant of theta. And I want to multiply it by this guy right here. So what am I multiplying that by? What do we call that? Starts with a C? The conjugate. Okay. So 1 minus cosecant theta. 1 minus cosecant theta. Okay. So here we go. Now, what would you recommend I do? We talked about this before. I would definitely encourage you to multiply the denominators together no matter what. But would you like me to multiply cotangent through 1 minus cosecant, or kind of just leave them separate as a product? What do you think would be better? Angel, what'd you think? I'm old. I can't hear. Leave it separate? Okay, let's do that. So I'm going to multiply these together, so I'm going to have one big fraction. So he says to leave them separate, cotangent theta times 1 minus cosecant of theta. Now, these are conjugates, so remember, I only have to multiply what two products? The first and the what? And the last. Could I go ahead and multiply the whole thing by FOIL? Yeah, it's just that the outside and insides are going to cancel. So what would you guys like me to do? Would you like me to just multiply the whole thing out? Just for practice or what? Yes? Okay, let's do it. So 1 plus cosecant times 1 minus cosecant theta. Okay, so let's multiply first. 1 times 1. 1. Now let's multiply the outside. So 1 times a negative cosecant. Negative cosecant. Now, if those are my outside, then the two middle are my inside. Cosecant times 1 plus cosecant theta. And then the last. Negative cosecant squared. Yes. And you'll notice what happened.
The middle cosecant cancel.
There you go. If they're conjugates, those like terms, they're always going to cancel. So what I'm going to end up here is 1 minus cosecant squared of theta. And actually, do you notice anything? Okay. Ooh, cotangent. There we go. Okay. And should it be negative? That's a good question. So let's see. What is the original Pythagorean identity that Brandon's referring to? 1 plus cotangent squared is equal to cosecant squared, right? Okay. So let's see. I want to rewrite this so that I have 1 minus cosecant squared. So if I subtract him over, what am I going to have to do? I'm going to have to subtract the cotangent squared over. Same thing here, what we did with the other Pythagorean identity. So 1 minus cosecant squared should equal negative cotangent squared. Would you guys agree? Okay. So I'm going to replace this with what we got from the identity. So let's see, we have cotangent theta times 1 minus cosecant of theta over. That's going to be negative cotangent squared of theta. So what can I do with that? Yeah, there. So that cotangent will cancel with that one. Okay. So you could leave the negative where it is, or you could go ahead and apply it through the numerator. Really, it doesn't matter. But I would say 1 minus cosecant of theta over negative cotangent of theta. Okay. And as long as we were able to get that denominator to one single fraction, that's good enough. That one's done. Yeah, that number's 5 and 6. Those don't simplify down to a single term like a lot of those we've been dealing with.
I think it's just equals.
Yeah. Mm-hmm. All right. How we doing? Okay. Well, I'm going to go ahead and turn you guys loose. Let you go ahead and take a look at the rest of those. Actually, don't have a whole lot left. You got 2 days. Remember, next Friday is what?
End of the 6 weeks.
The end of the 6 weeks. So our exam is tomorrow. It's 10 multiple choice questions. You'll be able to use your notes on that. Okay, so, these last grades, please make sure that you're trying to do as best as you can. Get your homework taken care of. All right, so if you have any questions, let me know. Thanks, guys. Well, stop right there. Can I shut that down, or are people still copying? And I'd say we got about, 13 minutes? 12, 13 minutes? So still enough time, to go ahead and maybe get at least 2 more knocked out. Okay. All right.